field lines, plus QE1 you have and minus QE2 you have. Means electric field that was uniform throughout. Now this is having E1 value and E2. Means the values of the electric field, these are continuously changing. Now if this is the case, then what will happen? See, earlier also when we were calculating the net force, we were getting plus QE1 minus QE2. Means when the electric field was same, we had plus QE minus QE. Force, this was the force, right? Now we cannot cancel it. Why? Because E1 and E2 both are different. And what about the torque also, net torque that is existing? You have P cross E1 and you have P cross E2. So you have the net force also, you have the net torque. So here you cannot say that the net force is directly zero. That's just what you have to remember if non-uniform electric field is given. Quickly write this. One question we will discuss based on this. Then we'll start another topic, electric field lines. That is a very easy theoretical portion you'll be able to understand. So that we can start with the last topic, that is Gauss theorem. Just write down this.
Done, ma'am.
Ma'am, could you go 1 minute up? I joined late. Thank you, ma'am.
See class, this says an electric dipole consists of two opposite charges of magnitude 1 by 3 into 10 to the power minus 7. When it says magnitude is this and signs are opposite, that means it is forming a dipole itself. And it's already mentioned in the question. So it means one charge is Q1 is minus 1 by 3 into 10 to the power minus 7. And this is separated by 2 centimeters, and you have Q2, which is plus 1 by 3 into 10 to the power minus 7 coulomb. The dipole is placed in an external field. Now, electric field which is existing is 3 into 10 to the power 7 Newton per coulomb. What is the maximum torque? Now, see class. Firstly, for the torque, torque's formula is P cross E. When you have P cross E, you write this as PE sine theta, correct? This is PE sine theta. So for E, we know electric field. This is E. What is P? P is the dipole moment. So you anyways have to take the magnitude of one of the charges and multiply it with the separation. So there wasn't even need that you should know what are these charges, because you just require the magnitude, which is 1 by 3 into 10 to the power minus 7. This is the charge. See, dipole is Q into 2A. What is 2A? 2A is the separation between these two. That means your 2A is 2 centimeters. So this is into 2 into 10 to the power minus 2. This is the separation. This much coulomb meter is the dipole. Now we have no information about sine theta. Can anyone tell me by looking at the question what should be the value of theta here? Look at the question.
180.
Khadija, what did you say?
180.
180 you're saying. See,
Yeah.
this is saying maximum torque.
Yeah.
Maximum torque means you have to get the value of sine degree maximum. If we take this as 180 degree, then that would give us 0. For maximum value, we have to have the value of sine degree maximum. And that can only be achieved when we have theta is 90 degree. So here you should already assume that theta is given as 90 degree. Then only PE sine 90 degrees, because sine 90 is 1. So torque will be PE, and this gives you the maximum torque. See class, that's why we have studied all those special cases. Remember, see, dipole is perpendicular to electric field, torque is maximum. Tell me class, is this angle concept clear to all of you?
Yes,
Can
ma'am.
explain again?
Yes, Mariam. I'll see. Once you have theta as 90 degree, sine 90 degree is 1. So if you
But
put
ma'am,
1,
the angle is not given in the question. Can you explain how to find out?
see, in the question, this is saying what is the maximum torque. So you know what is the maximum torque. In the last class, we have discussed that maximum torque is achieved when the angle is 90 degree. Clear?
Okay, ma'am, yes.
Okay, because why? When you have theta as 90, sine 90 becomes 1. So when you write torque as PE, this is the maximum value. Otherwise, when we were taking 0 degree, 180 degree, any other value, that was just coming 0. Because it is mentioned in the question to take and consider maximum torque. That's why we have considered this as 90. Now you just have to multiply this dipole moment which you have got into this value of electric field, which is given 3 into 10 to the power 7. So minus 7, 3 gets cancelled. Torque is 2 into 10 to the power minus 2 Newton meter. Directly you can write this as Newton meter. This is the value of torque that you have. This is what you had to remember. Write it down.
Ma'am, can you please show the question once?
Yes, Khadija.
Can you show the question once? Okay, ma'am. Thank you.
class. Now we have the concept of electric field lines. So electric field we have studied, but see, field lines are actually not existing. The way we have a concept of electric field, and to understand concept of electric field lines. So what happens here is that we have the geometrical and pictorial representation of electric field, which is written over here. But see, these are not actual curves which are existing and that you can see. These are just hypothetical curves because these properties of electric field will only help us define certain things. Now, electric field lines are existing around the charge where we have the electric field. So just to represent the electric field, how can you represent electric field? See, it's an abstract thing. You cannot draw it on yourself, right? And that's why we have this concept of electric field lines. And a full question comes on this. Individual properties are rarely asked. Usually you have the entire set of properties asked as a 5 marker, 4 marker. So you have, whenever a question comes from electric field lines, write it down somewhere that you have to mention all the properties unless stated. If it is stated, just mention 2 properties, 3 properties, 4 properties, that's a different thing. But if it's not mentioned, you have to list all the properties of electric field. Do not write it in detail, depends on the marks. If it's a longer mark question, write everything in detail. It's a short marker question, then write down, but you have to mention all the properties. So electric field lines are curves that such that a tangent to them gives direction of electric field. See, these curves are representing the electric field lines. All right. These are the curves which are representing the electric field lines. A tangential line on this, when you have this tangent, a tangential line on this gives us the direction of electric field. Because after you have electric field line, you ultimately have to understand and relate it with electric field. So it was observed that when this concept of electric field lines, this was deduced, it was observed that whenever electric field was to trace, a tangent could give us the direction of electric. So all these were done experimentally, and these electric field lines concept is only hypothetical. Actually, you have the concept of electric field that exists. But just to have the idea of electric field, see, if you have electric field lines, a tangential on them would give you the direction of electric field. That's why we have this concept. So write down this page. Let me know when you're done. We'll start with the individual properties because those properties are important. They're easy, but they're important for you to know. Class, just one more thing before you take your time to write. Just one thing. Can you just let me know in the chat column till when you all are available today? Are you available till 10:30 IST or you are available till 11 p.m. IST? Just text me in the chat column, all of you at least. 10:30. Just tell me in terms of IST. 10:30 or 11. All right, all right. Just one more thing, class. So on Thursday, I just want to increase the class duration now because we have now all of you are familiar with it. Today I'll not take. Okay, 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 all of you. Okay, so some of you are available till 11, but most of you are available till 10:30 today. It's okay. Just let me know. Should I start and increase the duration of, because I want to wrap up this chapter now because it's taking a lot of time and we had this bridge course also that elongated the time and we couldn't have the class during the break, Eid break that we had. So tell me on Thursday, should I take 2 hour class means 9 to 11, 11 IST or from next Tuesday?
No, I'm from Thursday, isn't it?
Just
Yes, ma'am.
reply me in the chat column. Is Thursday fine by all of you, or is if any even one student is not available on Thursday, let me know. I'll just change the time. If you all are available, okay. Thursday we'll have the 2-hour class. If anyone is not comfortable, you can text me. Thursday then I'll take 2-hour class. Okay, okay. Then class today I'll take a short class, but on Thursday we'll complete. Then from Thursday onwards, all the classes would be 2 hours, so that we can at least now put in time. Because see, you all in all of your school, 3 chapters are coming in your UT. June also some people are having, and most of you are having the tests on 11th May. Also, some of you have texted, so we have to cover that portion also. Zaina, I think Zaina has her exam on 11th. Okay, class. Thank you. You can write this down, then we'll start with the properties. Okay, class, just understand the properties first. You can write it down later. So, tangent to electric field lines gives the direction of electric field. This we have discussed. That's the first property. Now, see, there is one concept here. Remember, you must have done in your class 11th about the streamline concept, streamline flow in your mechanical properties of fluid. So, in that case, two streamlines can never coincide. You have studied this point in your fluids chapter. So, here also the same thing. See, if you have two curves coinciding, look at this figure. If two curves are coinciding, so this A point is a common point. Look, this A point is a point on this first one also, and this A point is a point on this second one also. right? So one direction of electric field is the C1 at this point A, and second direction of electric field at this point is E2. But is this ever possible? Can we have two directions of electric fields at a common point? You cannot have at one point that will give you one direction of electric field. That's why two electric field lines can never coincide with each other, because at the point of intersection, two tangents will be drawn, and that will mean that two different directions of electric field exist, so which is physically impossible. That's why we do not have this concept of crossing of electric field lines. Then second point says that, see, wherever electric field lines are located closer to each other, and there are places where electric fields are located far away from each other. So this closeness, when you see, that tells you that the electric field is very strong in this region. And wherever you see this distance, it means electric field is relatively weak. So suppose this example, look at this section 1, 2, and look at this 3. These are 3 electric field lines. So this is one section A, this is the section B. So EA is greater than EB. All right, EA is greater than EB. So this shows that relative density or separation of field lines gives the strength of electric field. Means in the region of stronger electric field, you will see electric field lines are closer. And in the region B, you will see they are far away, far apart from each other. That shows this side is weaker. So by this also you can analyze about the electric field lines. Third point I'll tell you later. First write down these 2 points. Done, class? Now look, the rest of the properties. See, this is an important property. That's why I wanted to discuss this later. See, for positive charges, we have discussed that electric field line, you always have it away from the charge. Remember? And for negative charges, we used to take the direction of electric field towards the charge. So same will happen with the electric field line only, because it is actually representing electric field. So you have a positive charge. That is, so when you have to draw the electric field lines for a positive charge, the field lines will be moving away from the charge lines. The field lines will move away from the charge lines. Like if you have a charge plus q coulomb, I have made fewer electric field lines. But when the magnitude of charge increases, see here the magnitude of the charge increases plus 2q, lots of electric field lines are increasing. So this is how you can differentiate between a higher magnitude charge and a lesser magnitude charge, lower magnitude charge. But the electric field lines here would be, here it would be less, here it would be increasing. Now here you have minus 2q. So see the electric field lines, all the arrows are pointing towards the charge. And when the magnitude is greater than this, so see the electric field lines are numerous. That's how you can differentiate and identify. See, from electric field lines, especially students who have to appear for their entrances after class 12. The questions on electric field is so obvious, and it is given so much where you have to identify the charges by looking at it. And especially these types of questions have come past in your JEE and NEET entrances where you have to identify. So similar thing you have to do over here. This is plus P, this is minus, and this is, so see when a dipole is made, all the rays are moving away. Look, all the rays are moving away. When this is a negative charge, all the rays are moving towards the charge. So this is how, so it looks like it is originating from a positive charge and terminating at the negative charge. It is not forming any closed loop. Starting from here, ending here. Starting from here, ending here. This is how you look in the case of dipole. If you have monopoles, this is the simple case, positive away, negative towards. For dipole, from positive to negative. And see, they are continuous curves. You do not have any breakage in between them. And electric field lines, when a positive and negative, both are present. Now, look, if a positive and negative means unlike charges are present. So you will see they contract longitudinally. Always you will see the word contract longitudinally. Now, what is the meaning of this term contract longitudinally? It's nothing. Basically, it's just explaining that when two charges, they are unlike, means alike charges are present, they'll attract each other, right? So what will happen? They will try to move towards themselves. So that is what is they are signifying contract longitudinally. Wherever you encounter this word contract longitudinally, just understand it means it is explaining you the attraction of charges. So definitely the charges are different in nature. But if the same nature of charge is present, suppose positive, positive or positive, negative you have, then the lines move straight away. Why? There is always a neutral point because they are repelling each other. So the field lines do not move. But if it was a case of positive, negative, we could see that it was originating from one point, terminating at another point. Fine. So EFL is electric field line exert lateral pressure on each other. There you see contract longitudinally. Here you are seeing the term lateral pressure. Now lateral pressure means they are expelled. This explains the repulsion of like charges. Why laterally means why sideways pressure is there? Because they are not meeting and here a pressure is being generated. All right. Write down till this point, class. This is the third point.
Madam, are you screen sharing? Ma'am?
She's not there in the class.
Class, am I audible now?
Yes, ma'am.
Yes, ma'am.